In this tutorial, we'll look at some common questions in the topic of chemical calculations, and by that we'll be focusing on your stoichiometric calculations, meaning those that involve the 3C approach where you have to compare mole ratio. And then we will also be looking at the different variations of chemical calculation questions in the form of excess limiting, your titration, your percentage U and percentage purity. Now the approach to solving these questions are largely the same. So you have to make use of the 3C approach, just that for different types of questions, there are different things that you need to look out for, and there are slightly varying approaches to each type of question. For this question, this is a classic stoichiometric calculation question where you can apply the 3C approach to solving the question. So let's recall what are the 3Cs. The first C is to convert to moles. So what can we convert to moles over here? We are given the mass of hydrogen peroxide. So the first thing that we can do is to find number of moles of hydrogen peroxide. Since we are given the mass, we can take the mass divided by molar mass, and molar mass of hydrogen peroxide is 34, and that will give us this number of moles. The second C is compare mole ratio. So compare mole ratio between what? Between what we have just calculated, or what is given in the question, and what we want to find. What we want to find would be oxygen. So the ratio can be observed from the coefficient in the balanced chemical equation, meaning 2 moles of hydrogen peroxide would produce 1 mole of oxygen gas. So that means that the number of moles of oxygen gas would be half of that of hydrogen peroxide, which will be this. So after comparing mole ratio, the last C is to convert from moles. So now that we have obtained the number of moles of oxygen, the question is actually asking for the volume. So we need to convert from moles to volume. And how do we do that? Is to multiply number of moles by the molar volume of a gas. Oxygen is a gas, so to find volume of a gas, we need to multiply by molar volume of a gas, and molar volume of any gas at room temperature pressure is 24 dm cube, so that would give us a final answer of 5.65 dm cube. This question is again a stoichiometric calculation question. Now, in view that this is an MCQ question, for MCQ questions, usually they don't require you to go through the entire painful process of evaluating the answer for each step. So usually it will be the case where the numbers are very nice, so you can do a mental calculation, or in this case, we are looking at the reactions of gases. So when we are comparing mole ratio between two substances and both are gases, then we can use what we call Avogadro's relation. When a reaction involves gases, the mole ratio is equal to the volume ratio. So that would allow us to solve this question very, very quickly. If we burn 48 dm cube of hydrogen sulfide, what volume of sulfur dioxide will be formed? So if you can see that both substances are gases, immediately we know that the mole ratio will be equal to the volume ratio, and the mole ratio given by the equation is 2:2 or 1:1, meaning 48 dm cube of hydrogen sulfide would also give 48 dm cube of sulfur dioxide. For this question, we are looking at a chemical calculation involving titration, and for chemical calculation questions involving titrations, usually there is a shortcut. Now we can still solve this using the traditional 3C approach, but if you recognize that it's a titration question, there's actually a shortcut in the form of this formula. Okay, C stands for concentration, A stands for acid, B stands for base, N stands for number of moles. So all you need to do is to substitute values into this equation and you can find whatever that you need to find. So this question requires you to find the concentration of your acid, meaning you need to find Ca. All we need to do now is to substitute the values into this equation. Now, the question tells you that the volume of acid is 25 centimeter cube. Now, the power of this formula lies in that you do not need to convert the volume into dm cube for reasons that I will show you later. Concentration of base is given, which is 0.015, and the volume of base is your titer value, so 24 centimeter cube. Once again, there's no need for you to convert to dm cube. Now, how about Na over Nb? Na over Nb is actually the ratio of the coefficient for your acid and alkali. So for this question, the equation is given to you, and we can see from the balanced chemical equation that the coefficient of acid to alkali or base is 1 over 2. So once you have substituted all the values, all you need to do is to perform the calculations correctly, and then you will end up with the answer. So back to the part of why is there no need for you to convert volume to dm cube, is because even if you were to do it, so if I divide by 1000 in the numerator and I divide by 1000 in the denominator, the 1000 actually cancels out. So when you are using this equation, when you are finding concentrations, there's no need for you to convert the volumes to dm cube because it will cancel out in the numerator and denominator anyway. So again, we can use the traditional 3C approach to solving this question. You will still end up with the correct answer, but if you can recall the formula and substitute the values incorrectly, it will be much faster. This again is a stoichiometric calculation, but we are looking at solutions and the concentrations is given in grams per dm cube. Now when you are given the concentration of a substance in grams per dm cube, my recommendation is to, before you do anything, to convert it to moles per dm cube. So for that we need to recall then how do we convert from grams per dm cube to moles per dm cube, or vice versa. Now the trick is to ignore the dm cube. Just ignore the dm cube. So from grams, how do we convert grams to moles? From mass, how do we convert it to moles? Is to divide by molar mass. And from moles, how do we convert to mass? Is to multiply by molar mass. So that is the conversion that you need to do. So given that the concentration of sulfate ions is 1.24 grams per dm cube, I first would convert it to mole per dm cube by dividing by the molar mass of sulfate. So that would be 31 plus 16 times 4, and that's 96. So I will get 0.0129 moles per dm cube. Now that I have gotten my concentration in moles per dm cube, the question tells you that the sulfate was precipitated with an excess of barium. So now we can calculate the number of moles of sulfate, which will give us the number of moles of barium sulfate as well, which is concentration times volume. So volume is 50 centimeter cube. Okay, the equation triangle that we are looking at is this. number of moles equals to concentration times volume. So when you're using this equation, almost all the time you need to take note of the volume. The units of volume is usually in centimeter cube, so you need to convert it to dm cube by dividing by 1000. So that would give us a number of moles of this. And the last step is this, that the question wants you to calculate the mass of barium sulfate. So from number of moles, how do we find mass? Is to take number of moles multiply by the molar mass of barium sulfate. And the molar mass of barium sulfate is 233. So that will give us a mass of 0.15 grams. Now when you read this question, you should be able to immediately identify that it's an excess limiting question. Now even if it's not stated, let me show you a feature that will tell you that it's an excess limiting question. And the feature is this, that the amount of both reactants are given in the question. What do I mean by that? The question tells you that you have 5.28 grams of butanoic acid, and they also give you the volume and concentration of sodium carbonate. So in this case, you are given the amount of both reactants. So when the amount of both reactants are given in the question, it's telling you that it's likely to be an excess limiting question. And to find out which one is limiting, which one is excess, step number 1 is to find number of moles of both reactants present. Okay, so I need to find number of moles of your butanoic acid. I'm going to abbreviate it by BA. So number of moles of butanoic acid would be mass divided by molar mass, and that would give us a number of moles to be 0.06. Next, we need to find the number of moles of your sodium carbonate present. Since it is a solution, we need to take concentration times volume. So 0.5 times 56 over 1000. That will give us a number of moles of 0.028 moles. Now that we have found number of moles of both reactants present, to know which one is limiting and excess, the second step is this, that we need to just pick one of the reactants. So for example, I would pick that of sodium carbonate. We know that we have 0.028 moles present. And then to compare mole ratio, to find the number of moles of acid required to react with all the sodium carbonate. Okay, so from the balanced chemical equation, we can see that 2 moles of acid will react with 1 mole of sodium carbonate. So number of moles of acid required will be 0.028 times 2, and that would give me 0.056 moles. And the last thing that's to be done is to compare the number of moles of acid required with the number of moles of acid present. And you'll find that it's less than 0.06, which means that it's less than the number of moles of acid present. If the number of moles of acid is less than the if the number of moles of acid required is less than the number of moles of acid present, that would mean that your butanoic acid is in excess. So we have shown by calculation that is in excess. So in order for you to make the conclusion, this particular line is very important. You need to show that the number of moles of acid required is less than the number of moles of acid present. Now we'll look at another limiting excess type question, and once again let us look out for that feature that I was talking about in limiting excess type questions. So for this question, you are given 15 centimeter cube of propane and 100 centimeter cube of oxygen. So once again, the amount of both reactants are given in the question. So this is a limiting excess type question. Anyway, the question tells you that your oxygen is in excess. So the question requires you to calculate the volume of carbon dioxide formed. This is the product. So in limiting excess type question, there's a second concept that is very important that you need to remember, is that the amount or the number of moles of product depends on the number of moles of your limiting reactant. Okay, not the excess. So to calculate the number of moles of product, we need to focus on the limiting reactant. In this case is your propane. So the amount of propane will determine the amount of product formed. Okay, for this question, it will help if you recognize that we are dealing once again with gases. So for gases, we can invoke Avogadro's relation, where your mole ratio is equal to volume ratio. So in this case, 1 mole of propane will give me 3 moles of carbon dioxide, meaning 15 centimeter cube of propane will give me 45 centimeter cube of carbon dioxide. Right? Without going through the painful 3C process, we can tell immediately from visual inspection and mental calculation that the volume of carbon dioxide is 45 centimeter cube. Next, we need to find the volume of unreacted oxygen remaining. So how do we do that? Again, is to compare the mole ratio between propane and oxygen gas. So the ratio is actually 1:5. So meaning 15 centimeter cube of propane would react with 75 centimeter cube of oxygen gas. And since we have 100 centimeter cube of oxygen gas present, the volume of unreacted oxygen will be 25 centimeter cube. Now for this type of questions, very often they will ask you to calculate the total volume of gases remaining, total volume of gases after the reaction. So for a question like this, you need to take note that there will be some oxygen gas remaining, and that would contribute to the total volume. Now we look at a percentage yield question. For a percentage yield question, it's very important for you to first recall the equation for percentage yield, which is actual mass over theoretical mass times 100. Now for percentage yield questions, usually the actual mass is given in the question, whereas the theoretical mass you need to calculate using 3C from the amount of some reactant. So for this question, we will just focus on part 2 and 3, which is to find the theoretical mass of ammonium phosphate, and then later on to calculate the percentage yield. So to find the theoretical mass of ammonium phosphate, we must first apply 3C to the reactants. So first C is to convert to moles. What can we convert to moles? We have the concentration and volume of phosphoric acid. So we can find number of moles of phosphoric acid to be 25 over 1000, concentration times volume again. And then C2 is to compare mole ratio between phosphoric acid and ammonium phosphate. So in this case, the ratio is 1:1, meaning your ammonium phosphate would have the same number of moles as your phosphoric acid. And the last thing is to C3 convert from moles. What do we convert to? We want to find the mass of ammonium phosphate. So we take number of moles multiply by the molar mass, which is given to be 149. Okay, so that would give us a value of 4.66. Okay, so once again, what we have done is to apply the 3C approach to find the theoretical mass of ammonium phosphate. Next, in part 3, we need to find percentage yield Actual mass is given in the question to be 2.93. So we take actual mass over theoretical mass times 100 to find the percentage yield of ammonium phosphate. Next, we look at a question for percentage purity. For percentage purity questions, the first thing you need to recall would be the formula for percentage purity, which is the mass of pure over the total mass of impure times 100. Now for percentage purity question, usually the mass of the impure substance is given in the question, and for the mass of pure you need to apply 3C to calculating the mass of your pure substance. Now in this case we are looking at a piece of chalk. The question tells you that chalk is impure calcium carbonate and the mass of your impure substance is given to be 23. So right now all that needs to be done is to find the mass of pure calcium carbonate. The question already tells you that the number of moles of calcium carbonate is 0.226. With that, we can immediately find the mass of calcium carbonate by multiplying by molar mass. Molar mass of calcium carbonate is 100, so it will be 22.6 grams. So next, the last thing, which is the percentage purity, would be the mass of pure calcium carbonate divided by the mass of impure calcium carbonate times 100. And since this is an MCQ, again, there is really no need for you to compute. If you look at the numbers involved, you can guess that it will be very close to 100%, so 98.3%.